these intervals. Suppose we have the absolute value of x plus 2 is less than 4. Now, the way we solve an equation like this, or actually it's an inequality like this, is to say that the number inside, x plus 2, if its absolute value is smaller than 4, then that number is smaller than 4, but also that number is bigger than negative 4. For example, x plus 2 couldn't be negative 5 because its absolute value would be 5 rather than smaller than 4. So now what I have is a double inequality, and to solve this, I'm going to subtract an x from all three expressions, or rather subtract a 2 from all three expressions. So this becomes a negative 6, just an x in the middle, and I have a 2 over here. And this means I'm talking about solutions that are bigger than negative 6 and smaller than 2. So I'll write that as the interval negative 6 to 2. By the way, some of the ways you wouldn't want to write it, well, obviously you wouldn't want to put square brackets on there because that would mean that you were including the endpoints. Also, you wouldn't want to use set brackets like this. And the difference is this means you're talking about exactly those two numbers, negative 6 and positive 2. And of course, neither one of those numbers are actually in the interval. We want the numbers that are in between those two. Okay, now in a little bit, in a slightly different problem, suppose we take the absolute value of 3 minus 2x is greater than or equal to 7. Now, this one's a little bit trickier to solve because you see, if I want the number inside to have absolute value 7 or larger, then there are actually two possibilities. 3 minus 2x could be greater than or equal to 7, or the other possibility is 3 minus 2x could be less than or equal to negative 7. For example, negative 8. This expression could be negative 8. Its absolute value would be 8, and that would be greater than or equal to 7. So I'll solve these two inequalities separately. In the first case, I have negative 2x is greater than or equal to 4. And if I divide by negative 2, x is less than or equal to negative 2. Or the other possibility is that negative 2x is less than or equal to negative 10. And when I divide by negative 2, x is greater than or equal to positive 5. The numbers that solve the first half of this problem would be the numbers from minus infinity up to minus 2, including negative 2. And the numbers that solve the other portion would be the numbers including 5 up to plus infinity. You can put a plus on the infinity if there's any doubt about what you would mean by that. And I want to put these two sets together, but not the intersection, because actually they don't intersect at all. It's the union, so I'll put a union symbol in between here, and then this is the solution to the problem. And when I put a union symbol, it means anything in the first set or in the second set is a solution. Okay. Let's go to a different review topic. This one deals with exponents. Let's just go over properties of exponents very quickly. Suppose I have 5 to the negative 2. What is another way of expressing that in a more familiar form? Anyone? Yeah, Jeff.
1 over 5 squared.
1 over 5 squared. Yeah, 1 over 5 squared. Or in other words, 1 over 25. If you have a negative exponent, that just means you invert that, the 5 squared, so you put that on the bottom. What if I had 3x to the 0 power? What does that mean? Or at least, how could I simplify that? Stephen?
X to the 0 power, or anything to the 0 power, is 1. So the answer would just be 3 in that case.
Okay, that'll be 3 times 1 or 3. You know, there actually is one qualification on that. Not anything to the 0 power is 1. 0 to the 0 power isn't defined. It has no meaning. If you take 0 to the 0 power, it's not 0, it's not 1. It just doesn't mean anything in mathematics. What if I put parentheses on that and said 3x quantity to the 0 power? What would that be?
1.
That would be 1, yes, because now everything's raised to the 0 power. And so assuming x isn't 0, 3x to the 0 power is 1. What about a fractional exponent like 9 to the negative 3/2 power? Now, first of all, what does that even mean when you put a fraction in the exponent? That's a 3 right there. Anyone who can explain not just what the answer is, but what this even means? Okay, I'll explain it. First of all, it's 1 over 9 to the 3/2 because we have a negative exponent. And then the 1/2 portion means take the square root of 9 But there's a 3 on that, so then I have to cube that answer. So the 1/2 portion of the fraction, that means take a square root, and the 3 means to cube it. So this is going to be, let's go down here, this is 1 over 3 cubed, and that's 1 over 27. Now another possibility is instead of taking the square root of 9 and then cubing it, you could have, as an alternative, you could have cubed the 9 and then taken the square root. I didn't do that because cubing the 9 makes it awfully big, and knowing the square root, which would end up being 27, is something I wouldn't have known right offhand. Let's take one more problem that involves exponents. How about this one? 6y squared over 2y to the negative 3. Let's see, to begin that problem, well, who can tell me, what would you do to begin this problem? If I want to reduce this. Stephen.
I'd distribute the squared into the parentheses.
Okay, what would you get in the numerator?
36y to the 4th.
36y to the 4th. So what he's doing is he's squaring the 6 and he's squaring the y squared. So he gets 36y to the 4th. What about the 2y to the negative 3? What would you do with that? Now, what's raised to the negative 3? The 2y or just the y?
Just the y.
Just the y. So what I'm going to do is put the y cubed up on top. This is a multiplication sign right here. But the 2 didn't get to move because the 2 didn't have a negative on it. You know, rather than a dot, I think I'll use a parenthesis on that. So now if I just reduce this, 36 over 2 is 18. And y to the 4th times y to the 3rd is y to the 7th. Yeah, y to the 7th. 18y to the 7th for that. Okay, let's move on to simplifying radicals. You know, before we do this, let's go to the next graphic there, and let me just tell you a little bit about what's available as a resource for this course. As you probably know from the information that you've been supplied, there's a website that accompanies this course. If you go to the UVSC website, if you go to MATH1050 telecourse webpage, and then you go to episode 1, there will be a number of pages that you can go through on your computer to see some of the things that we've demonstrated right here. But along with the review discussions on the website, you'll see 18 problems that I've made up along the way. Those are not to be turned in, but they're supposed to be for your benefit. You can sort of practice some of the things that we've been doing here. So if you look on the website, you might try working those 18 problems that I have available for you. And the answers will be in episode 2. I won't discuss the answers in the classroom here, but if you look on the website for episode 2, you'll find all the answers for those problems. So you can check your work. And if you find a few of those a little difficult, that's okay. I don't think that's too serious. But if you have trouble working all of them, I think that means you might want to reconsider whether you want to take Math 1050, or you may want to drop back and review Math 1010 as a possibility. But some of those problems I think are fairly easy. Some of them are rather complex. And it's supposed to give you a sort of a general review of a number of ideas. Okay, let's go to simplifying radicals. Now, when I mean a radical, I mean a square root, a cube root, something like that. Suppose I have the square root of 75x cubed. Now, this radical isn't simplified because I can find some square factors in each of these numbers. In 75, there's a square that divides it, and in x cubed, there's a square. So what I'll do is I'll factor out the 25 and an x squared, and what would be left over is my missing factor here?